Lesson 3.4, Seafloor Spreading, Hypothesis, not a theory, hypothesis. Outline, so the objectives are to be able to outline the seafloor spreading hypotheses and to describe how seafloor spreading works. It's actually kind of cool. So how do the continents move? Harry Hess was a geology professor and a naval officer. He commanded an attack transport ship during World War II. He was intrigued by the seafloor maps produced with the ship's echo sounder. He thought about all of the evidence for continental drift. He thought about all of the unusual features on the seafloor, and he found the mechanism to explain them all. Now, kids, so Wegener, back in the late 1800s, early 1900s, came along and said, hey, these continents are moving and here's how it's working. Now, but he didn't have proof. Now, Mr. Hess comes along and he says, oh, here's the proof. The evidence comes together. World War II allowed scientists to make some puzzling observations. Deep trenches are found far from the ridges. Guyats have eroded tops that are deep below the sea level. Kids, guyats are just mountains, but the tops are very eroded. So that's one. The magnetic polarity of the seafloor changes. Kids, the center of the ridge is of normal polarity, but then there are strips or stripes of normal and reverse polarity found on both sides of this mid-ocean ridge, and I'll show you more about that. The youngest seafloor is at the ridge. The oldest seafloor is further away from the ridge. So kids, the oldest seafloor, though, is still much younger than the oldest continent. Kids, this is in the middle of the ocean, kids. This is where we're getting new land, okay? Although it's underwater, it'll eventually become land. Scientists needed to explain these observations. The mantle convection. Not long after Wegener's death, scientists realized that there is convection in the mantle. Deeper material is hotter, and so it rises. Near the surface, it becomes cooler and denser, and so then it sinks. This creates a convection cell in the mantle, and it just kind of goes up and cools off, comes back down, heats up, goes up, kind of like a lava lamp. Seafloor spreading. After the war, Harry Hess put together the ideas and evidence he needed. Hess resurrected Wegener's continental drift hypothesis. He reviewed the mantle convection idea. He thought about the bathymetric features, so on a tectonic plate, there's the continent that's outside of the water, and then around the edges on all of the continents, there's this part of the plate that's under the water. It's all together on one tectonic plate. It's just some is out of the water, some is in the water. So bath is in the water. He thought about the bathymetric features and the patterns of magnetic polarity on the seafloor. In 1962, Hess published a new idea that he called seafloor spreading. Hess wrote that hot magma rises up into the Rift Valley at the mid-ocean ridges. The lava cools to form new seafloor. Later, more lava erupts at the ridge. The new lava pushes the seafloor out horizontally away from the ridge's axis, or right down through the middle. The seafloor moves. Okay, magnetite crystals in the lava point in the direction of the magnetic North Pole. The different stripes of magnetic polarity reveal the different ages of the seafloor. In some places, the oceanic crust comes up to a continent. The moving crust pushes that continent away from the ridge axis as well. If the moving oceanic crust reaches a deep sea trench, the crust sinks into the mantle. The creation and destruction of oceanic crust is the reason that continents move. So there are times, kids, when the lava, the magma comes up and pushes those plates apart. Kids, there's sometimes when it actually part of it goes down and part of it goes over, and we'll talk about that. Let's see. Then we've got this picture. As oceanic crust moves away from the ridge crust, it pushes a continent away from the ridge axis. If the oceanic crust reaches a deep sea trench, it sinks into that trench. The oldest crust is the coldest and lies deepest in the ocean. Well, that makes sense. Okay, the flat-topped guyats were once active volcanoes that were above sea level. They were out of the water. They were eroded at their tops. As the seafloor moved away from the ridge, the crust sank deeper. The tops of the guyats went below the sea level. Now, the mechanism for continental drift. Seafloor spreading is the mechanism that Wegener was looking for. Kids, a mechanism is the explanation for how something could happen. If you don't have a mechanism, you don't have anything. Okay, convection currents with the mantle drive the continents. The continents are pushed by oceanic crust like they are on a conveyor belt. Over millions of years, the continents move around the planet's surface. The spreading plate takes along any continent that rides on it. But kids, honestly, this takes millions of years. So at some points, kids, all of the continents are together. At some points, they kind of spread apart. And then, kids, eventually, they're going to come back together because that's just what our Earth does. Okay, so we've got the summary here. Now, guys, so this map right here, you can make this bigger by clicking on it and making it bigger so that you can see it. But notice these little arrows, kids, are showing you, okay, now some of them are dots, but some of them are arrows. Kids, they're showing you the direction that those plates are moving. And so when we draw these lines onto our map, kids, we want to make sure that we get those arrows. And the map is right here. And so, kids, I don't know how you're going to do this on the computer. Maybe you can copy this into the drawing tool. But honestly, kids, if it was me, I would just I would print a copy if that's at all possible, and I would draw on it, and then I would take a screenshot and save it as a PDF. If you don't know how to do that, kids, let me know and I'll make a little video about it. Otherwise, kids, Google it. How do I make a PDF so that I can send it to my teacher? I hope that things go well. And kids, this map work, this is pretty detailed stuff. So I'm not going to have this due until November 23rd. Okay, 24, 25. Well, it'll be right before Thanksgiving. Have a good night. I'll see you later.